this channel, we are looking at repeated eigenvalues. We want to look at three cases in this case. Okay, and we'll start with consider this system. Consider this system we're talking about. Okay, consider this system. Okay, and we said in the previous video that to get the solution, the general solution, we need to find the eigenvalue using this expression. Okay, and also to find the eigenvector, we need to solve this system. We need to solve this system. Okay, so these are the things we discussed in the previous video. So we want to look at three major cases that can happen on repeated eigenvalues. Then case one is the case of R1 is equal to R2 is equal to 3. Okay, and then the third one is minus this. So whereby this eigenvalue generated two eigenvector, first one and then the second one. Okay, then the solution for the respective eigenvector will be this as a function of t, and then this one also as a function of t. So these are the solution for the respective eigenvector. And then for the third one, you have what your solution, which will be what? Which will be this. So in that case now, the general solution will be equal to C1, C2, and then plus C3.
Yeah.
Okay.
Yes. Find the general solution of this system. Okay. The first thing we need to do to solve this system is to step one, to calculate eigenvalues. This is the first thing to do. Then to calculate for eigenvalue, for eigenvalues, we use determinants. We use this expression. That will be the main diagonal here, minus r, minus r, minus r. This minus r, this minus r, this minus r. So we have this. So r is will be subtracted from the main diagonal, equal to what? Equal to 0. Okay. So let's solve this to get the eigenvalues. So this will be, I'm using the first row. So we cover this, So I have this. Then minus this is minus 2. So times minus. So that's plus 2 into bracket. Cover this one also vertical, cover it horizontal. So I have minus 2, 2, then 2, 1 minus r. Then the last one, that's a plus 2. Plus 2, do the same thing also. Cover this place vertical, cover this place horizontal. So I have minus 2, 1 minus r, 2, 2, equal to 0. So that's what I have. So we can do so we now have 1 minus r, this one times this one. So we have what? We have 1 minus r squared. And then this times this, that's minus 4. Minus 4, you close that. Then the second one, plus 2 into brackets. this one times this, so that will be 2 into bracket 1 minus r, then minus 4. So we have this to bracket this one times this one, so that will be r minus 1 minus r or square, then this times this, so that's minus 4. Minus 4, you close that bracket. Then the second one, plus 2 into brackets this one times this one, that's minus 2 into bracket 1 minus r, then minus 4. You close the brackets. Then the last one, that's a plus 2 into brackets this one times 2 times minus 2, that's minus 4 into brackets minus this one times this one, that's 2 into bracket 1 minus r. You close the brackets, and that equal to what? Equal to 0. So what we do now, so we now have this, and we have this. We can expand this. If we expand 1 minus r squared, that will be 1 minus 2r plus r squared, then minus 4. Okay? Close that one. Then plus this one, 2 into brackets this one times this one, minus 2. This one times this one, that's a plus what? Plus 2r. Then minus 4. Okay, then the last one, plus 2 into brackets minus 4. We can open this one, open the bracket, minus 2 times 1, minus 2 times minus r, that's a plus 2r, equal to 0. Okay, then we have this. We can arrange this one, which will be r squared minus 2r, then 1 minus 4, that's minus 3. Okay, then plus 2 into brackets. We have 2r minus 2 minus 4, that's minus 6. Then plus 2 into brackets 2r, the one here, then minus 4 minus 2, that's minus 6, equal to 0. So what we can do now, we have this. This one, we can factorize it, and this will be this. We'll pair this into 2, 1 here, 1 here. Factors of 3 that can give us a minus 2, either by adding or subtracting. That will be minus 3 plus 1. Okay, so these are the 2 factors. Then here, 2 goes here. We can take 2 out here. So that will be what? That will be plus 2 times 2. Okay, into bracket what? R minus what? R minus 3. Here also, 2 goes. You can take the 2 out. That will be 2 times 2 into bracket what? R minus what? R minus 3 equal to 0. Okay. In this first part, R minus 3 is common. It's common here. It's common here. So we can take it out. Then we have this. And that will remain 1 minus r times r plus 1. Okay. Then the second part, that will be 4. And the third part, that will be 4 also. Equal to 0. Then we can expand this. 1 times r, that's this. 1 times 1, that's plus 1. Minus r times r, that's minus r squared. Minus r times 1, that's minus r. Plus 4, that's plus 8. Equal to 0. So we now have r minus 3 into brackets minus r squared. This one and this one we cancel. Then we have plus 9 equal to 0. Okay, we can take this minus out. We can factorize minus. Then we have this. Then this will be what? R squared minus 9 equal to 0. We can also multiply through by minus so that this minus can leave this place. Then we have this. This one is a difference of 2 squared, so that will be r minus 3 into bracket what? R plus 3 equal to 0. So finally, this will be equal to 0. Also, this one is also equal to 0, or r plus 3 equal to 0. So we now have r1 equal to r2 equal to 3, and r3 is equal to what? Minus 3. So the eigenvalues, these are the eigenvalues. To get the eigenvector for r equal to what? R equal to 3. We use this we solve to get the eigenvector. Okay? And don't forget your r is what? Your r is 3. This is r value. And what that means is that if you remember from the beginning, we said what? We said this main diagonal minus 3. So that's the meaning of this place. Just go back to your question. Go back to your matrix A. So these are matrix. Okay? That's our matrix. So that will be 1 minus 3. That's minus 2. Minus 2. 2. Minus 2. The main diagonal, 1 minus 3. 1 minus 3. Minus 2. 2. 2. 2. 1 minus 3. Minus 2. Then the component of the vector here, of the eigen, this is the eigenvector. That will be U1. Since we have the matrix is 3 by 3, so we're going to have U1, U2, and U3 equal to what? 0, 0, 0. Okay, this okay. Then the next thing to do now is to get the augmented matrix. Augmented matrix, and that will be combinations of this matrix and the equal value. So and that will be minus 2, minus 2, 2, minus 2, minus 2, 2, 2, 2, minus 2, combined with the equal value. So that's the augmented matrix. Then we solve that. Then we can combine, we can get R2 is equal to, R3 that will be equal to R2 minus R1. Okay? Then R3 is equal to R3 plus what? Plus R1. So our reference point is the R1, the row 1. That one is not changing. That's the reference point. Okay? And that will be minus 2, minus 2, 2, 0, 0, 0. So, minus 2 minus 2. So it's 0. Second one also, 0. Then 2 minus 2, 0. The third one also, we're adding row 3 plus row 1. This will be 0 also. Row 3 plus row 1, 0 also. 0 also. So that's what we have. Then we can quickly, don't forget the first column is for U1, U2, U3, the third column. So that means for row 1, minus 2 times this, and then minus 2 also times U2, so minus 2 U2 plus 2 U3 equal to 0. Then we can solve for minus 2 U1 is equal to, move this one to the other side, that will be U2, 2 U2 minus what? Minus 2 U3. Then minus U1 is equal to, divide this one by 2, by 2, by 2. So we have U2 minus U3. So you can multiply by minus, then U1 is equal to what? U2 plus U3. So consider U2 to be this, and U3 to be T. Okay? So in that case now, the eigenvector, the first eigenvector will be equal to U1 is what? U1 will be minus x plus t. and then u3 is what? Is this, and u3 is t. Okay? Then we can separate these variable into two parts. So the eigenvector will be equal to, for the first variable, minus x here. There's no x in the third part here. So that would be what? That would be 0. Okay, then plus. The first equation we have t, the plus t, followed by, there is no t here in this second one, and the third one we have t. Okay, so we can factorize the alphabet, the x. If you take it out here, then you have minus 1, 1, and 0, then plus. Do the same thing also. Take the t out, then that will be 1, 0, 1. Okay. Therefore, the eigenvectors are these brackets. That's this. So these are the eigenvectors. We can get the solution. The solutions is for x1. For this, the solution for this eigenvector, that will be equal to this value, minus 1, 1, 0, then times exponential. This, and we can put C1 here, then that's C1, and then the second one, is C2. The second solution will be C2 into brackets. The last one, 1, 0, 1, and then times exponential 3t. So these are the two solutions for that particular eigenvalue. Okay. Then the eigenvector for r equal to minus 3, we solve for this. That will be plus 3i equal to this, equal to 0. So we solve for this, for the eigenvalue r equal to 3. Okay, so that's very simple. Why is it plus 3? Because the value is what? Minus 3. So initially, this is the function r minus a minus r times I, eigenvector equal to 0. So if you plug in minus 3 here, you have your plus 3. So what we are going to do, we just go back to the main diagonal, plus 3, plus 3, plus 3. So we have what? 4, minus 2, 2, minus 2, 4, 2, 2, 2, and then 4. Then the component of these are u1, u2, u3 equal to what? This one is also a component, that will be 0, 0, 0, because this is 3 by 3. So from here we have 4 minus 2, 2, you put your slash, your line, 0, 0, 0, then here minus 2, 4, 2, 2, 2, 4. That's the augmented matrix. Row 2 will be equal to, we can make it 2 row 2 plus row 1. Then row 3 will be equal to 2 row 3 minus row 1. Then that will give us this one. So minus 2 times 2, then plus 4. So that's what? 0. So row 2, that's 0 here. Row 1 is not changing. 4 minus 2, 2. Then the second element in row 2, that's 4 times 2, then plus minus 2. That's what? Now it's 6 here. Then the third in second row, the third element there, here, times 2, that's 4, plus 2, that's 6. And this will be 0 plus 0, that's 0. Then row 3 now, 2 times row, this will be here, times 2, that's 4. So we have 4 minus 4, that's 0. Then the second element in the third row, times 2, that's also 4, that's 4. Then minus 2, that's 6 also. Then the last element there, this one, 4, times 2, that's 8, that's 8. Then minus 2, that's 6, that's 0 here. So we now have from the third row, either from the third or second row, from the third row, so we have 6u2 plus 6u3 equal to 0. So u2, 6 we cancel out. u2 is equal to what? Minus u3. Okay? And then from the first row, we have 4 u1 minus 2u2 plus 2u3 equal to 0. Then we have 4u1 minus 2u2 is what? u2 is a minus u3 plus 2u3 equal to 0. So we have 4u1, this one times this one, that's plus 2u3 plus 2u3 equal to 0. So we have 4u1, 2 plus 2, that's 4, that's 4u3 equal to 0. Okay? So 4 can also cancel out. 4 can cancel out. Then we have u1 equal to what? Minus u3. Okay? So consider u3 equal to what? Equal to x. Okay? So in that case now, u2 is what? u2 is what? It's minus x. And then u1 is what? u1 is what? u1 is also minus x. Okay? The third eigenvector will be equal to u1 is what? Minus this. u2 is also minus this, minus x. Okay? And u3 is what? Is x. Okay? We can factorize this variable, this x out. We have minus 1, 1. So the solution for this particular system, the solution is what? Is that'll be the third one. The solution is what? The eigenvector minus 1, 1, 1, and then e minus 3. See? So that's the solution for that. And this one is our eigenvector. This one is our eigenvector. Okay? The eigenvector is what? The eigenvector is minus 1, 1. Okay? So the last thing to do now is to get the general solution. The general solution is equal to C1, the eigenvector, which you have 1, 0, 1, this one, then plus C2, minus 1, 1, 1, then plus C3, minus 1, 1, E exponential for this system.